Please welcome Matthew Park.
Hey guys, thanks for coming out. My name is Matthew Park. I am a user experience lead over at Endgame. Real quick, Endgame, it's a EDR and EPP platform. The context of this is we're building an attack timeline visualization, which I'll be talking about during this talk today. So this is something we're currently prototyping within the product. And what our company does is they build endpoint protection across enterprise-wide kind of stuff. What my team does in general is what we do and what we care about are kind of building thoughtful and practical workflows, like visualizations, and general experiences for cybersecurity analysts. So we really care what the users do 100% of the time. That image to the left is it's not supposed to make sense. It's a joke. Defining what UI and UX is. But I got a lot to go through, so let's just start it out. All right, I had to do that. I would be totally remiss if I didn't actually put a video of actual war games in there. For you guys that aren't familiar with what war games are, it's a film back in like 1983. Basically, the Americans created this thing called the WOPR that like kind of go through these wartime simulations during the latter portion of the Cold War, and it's supposed to like have us have the leg up in the nuclear arms race. At this point of the movie, the WOPR can no longer tell between reality and kind of fiction, and it's trying to brute force its way into NORAD and getting the codes. So Matthew Broderick is kind of like yelling at it, trying to get it to understand the futility of war by kind of like this tic-tac-toe simulation. So it's very surreal. I highly recommend watching it, but it's kind of ridiculous. But I'm going to segue into that by saying it's ridiculous for something totally unrelated to it. For those of you who've seen the movie, SOC analysts and the actual like generals make the majority of their main decisions and driving components primarily based on all the WOPR visualization. I can honestly count like maybe between two fingers the amount of times a SOC analyst has like a Unix shell open versus when they're like mouth agape in front of like all these types of visualizations out there. And you can actually see, like in a typical SOC, obviously you have kind of visualizations up on the board, but in their individual monitors over there, they actually have just the same things just kind of strewn about around the SOC floor. And I kind of came to this conclusion after watching this movie for the fifth time leading up to this talk, that the only way that this kind of makes sense to me is, I guess, that this visualization was pretty practical for the 1983 version of NORAD out there. The designs are like pretty minimal, simplistic, relatively easy to understand. I guess it had the SOC analyst mindset of a NORAD analyst, which is kind of contradictory to what this talk is about, or what it was framed as. Still home of the WOPR? Not exactly, because visualizations as we know it today don't really have the main like driving decision force that the WOPR had in this movie. Analysts generally don't like dictate their workflows based on what they're going to be seeing in like some sort of pew-pew map. So it was really never home of the WOPR whatsoever. Spin, plot twist. As we know, analysts today kind of are more comfortable sifting through like a stream of events through like typical heavy list views. And they're more comfortable doing that, and they form these patterns around how they're taking the metadata from those individual list views. And what they generally view visualizations as, of what I found, it's kind of bogging them down and being a little bit more time-consuming and generally useless. So I took this quote from this guy named Raphael Marty. He wrote a book called Applied Security Visualizations, which is pretty good. And he talks about the general problems plaguing security visualizations today. He says they're either the work of designers with no background in security whatsoever, or they're the work of security professionals who don't really understand data visualizations. One is generally pretty beautiful, but not practical in getting work done. and the other is relatively effective, but it's kind of non-intuitive. It requires the average analyst to do a lot more work in actually piecing together the story. And generally, as an industry, we kind of lean towards the latter of these visualizations because A, they're easy to build. You can just take them straight out of like a D3 library. And it's kind of a disappointment because we tend to lean on stuff that's kind of familiar to what we've done previously rather than make a focused effort towards usability in general. Which leads me into attack timelines. This is the outline of the talk right here. WOPR right there. So this is a talk around attack timelines in general. It's actually disguised as a usability talk around attack timelines. Surprise. So at the end of this talk, I'll be kind of discussing and showing a couple concepts around some prototypes that we're currently putting together through Endgame. But these kind of designs aren't really the key takeaway I want like this group to leave with. It's more around, my hope is as I discuss the approach of how we came to this conclusion of what we should be doing for our attack timelines, you guys can take these key principles back and broaden your own perspectives about how you should be approaching your own set of visualizations, whether or not it's attack timelines or anything else in particular. I firmly believe in order to introduce any sort of visualization in general that's functional and can be usable to like whoever, the people that build it first need to understand, like do the proper research into design structures and understand their user base to make their correct decisions. So going into it, surprise, I am a user experience designer, so we went through a very user-centric approach to discover what exactly is needed for attack timelines. And we kind of split this into 3 individual stages. The first being discovery. Coming from Endgame, we had certain biases coming into what the attack timeline should be because people within our organization have worked previously with them. So we wanted to confirm whether or not those were actual things that were currently out in the wild. We had an opportunity to test a large amount of participants through actual SOC organizations as well as our own internal. So we ran a couple user research testing and to capture kind of the organizational workflows from them, as well as creating a new persona paradigm specifically around alert triage and attack timelines. The next phase is concepting. So through all the data that we collected, we eventually came up with a couple design requirements that gave us the guidelines to form what the version of the attack timeline was. And we revisited some tried and true old basic foundations of what design patterns should be around. And then the last phase, which is prototyping and user testing, this is something we're currently in. I'm not going to be demoing like an actual working thing, rather explaining and showing some designs that we've been going and actually are currently building with our dev teams now. The hope, again, is to take that back out into the wild and test it among the users that we previously researched with or whoever wants to get their hands on it. So getting it straight into the discovery phase, I'm going to walk through each one of these things. Us as an organization, we wanted to define exactly what an attack timeline is, to have like a basic understanding or a consensus of what everyone thought, what we were trying to accomplish. And I'll just read this straight off as we wrote this down. So the goal of an attack timeline, or an alert triage visualization, however you want to put it, is to allow an analyst to quickly assess the relative severity of an alert so they can dismiss, remediate, or escalate to another analyst. It really serves as a means to communicate a story of an attack, because it's generally just a story, like a lot of visualizations, and should be used as a platform for data manipulation and general exploration. Like I said before, coming from an organization that had prior experience this kind of stuff, we also had a couple other biases going into it. So we found that large groups of users, generally like tier 1 users, generally lack domain experience in the security field, as well as platform experience on a lot of other security platform products, which made a lot of the visualizations that were currently up just in the ecosphere of security products kind of difficult to navigate because some of them are kind of overly complicated. They return a lot of information back to the user, and they really provide no context of where they should be going or how they should be remediating it up or down the chain. So that's one. The one is the lack of time, and this is just a general problem among SOCs in general. Repeated that twice. They have like 5 to 10 minutes to make a decision on an alert. So typically they're looking at streams of like hundreds or thousands of different types of data. So without context, without knowing what they should be looking for, they have to make a split decision whether or not they're going to be sending it up the chain or they're going to be archiving this as something that's nothing they really need to be looking at. The last one was kind of our own thing towards endgame. We wanted to build something that was kind of a bit of more of a differentiator. We wanted to build something that kind of enhanced the analyst workflow, something that they'd actually use and not be useless eye candy. So the list of different things that we added to that were showing response actions, being able to gather on large amounts of data and make like different types of investigations off of it, building some context to alerts already taken, or to actions already taken on particular alerts, if an IP changed, if you killed a process, if you suspended a process, and general collaboration and commenting kind of. Something that we found, and I'll get into this a little bit more, is as people are communicating up and down the chain within a SOC, it's very difficult for them to kind of show what they're actually working on, as well as communicate whether or not alerts are actually bad. So knowing these biases, we came into the study where we got like 3 participant groups, and we wanted to be able to capture different types of team dynamics among the workers' roles within the security organizations. We wanted to form our own unique personas off of all of them, as well as kind of see how they work through alert triage in general. We've done this multiple times on multiple features, but this one was kind of segmented directly off of alert triage and attack timelines. I'll walk through this really quickly, but the first one was traditional SOC team. So we got 20 people to participate, asked them a set of general broad questions around alert triage and attack timelines to give us kind of a bucket of responses so we can see where they should be going, where we should be going with the feature. The next one was a version of our own A/B testing. So we had an actual live SOC team that was participating in a red versus blue exercise. So we mimicked the exact same thing, or tried to mimic the exact same thing internally. And that included like general just side-by-side monitoring with other researchers at Endgame, data scientists, product people. We had some user interviews that kind of hit on the same questions that we asked user group A. And we had a larger retrospective at the end where like a 2-hour session where these people got to air their grievances on where they felt attack timeline should be going, how they were dealing with alert triage, what they wish was there like within the product at that point in time. So that was how we collected all this data back, and it was a lot. This is a wall of text, but this is the basic 4 types of personas that we came out of this group. And I'll go through this really quickly as well. It's so a tier 1 analyst, again, has generally no experience within the domain or a security platform in general. They're more comfortable working through the UI. They are the first line of defense within a SOC organization. They they look at the alerts coming in, and they have to make a split decision whether or not to send this up to a tier 3 or a forensic hunter, or to just like throw it down into a queue. That doesn't really matter. The tier 3s take this, and they actually have the authority or the power to make actionable responses on top of this. Both of these guys don't really use the UI too much. They're more comfortable working in the command line. They just want to rip the APIs out and like work directly off of that. So they generally regard visualizations as kind of tiresome and like a little bit overbearing. And the last one is a SOC manager. So the SOC manager kind of sets the tempo, schedules. They really care more about collaboration and reporting purposes. They want high to low level visibility of what's going on day to day within individual alerts or trends as a whole. So this was kind of the spectrum different users we were trying to cater towards when we were building the attack timeline. We boiled down to a couple perspectives of what we found throughout the entire group. So in general, the first two were more variables and a representation of time. When we were opening the attack time visualization, there was a general consensus that there was a lot of data streaming through, and whatever we were going to build and whatever people currently had previous experience working in attack timelines, they generally thought that we couldn't stream the amount of data that an individual sensor could provide back to the platform. So that was a worry. That was a worry among a lot of different types of analysts. There's that representation of time. Quote I got from one of these guys is, time is kind of a relatively abstract concept, so it's not inherently visible in general. And we force this not inherently visible perspective in a very linear plane. So when visualizations come out, they're either forced in a linear perspective or it's just removed completely. It's just based off connection patterns. So analysts like to know, obviously, when an event first started to when it triggered, but they would generally like to know kind of the connection patterns of time between those two events, which is currently lacking in a couple attack time visualizations out there. The next two was lack of expertise and lack of time. These were our two biases coming into it, and we kind of got these confirmed. This is more on the tier 1 perspective. They wanted more context of why they should be remediating alert through a type of visualization. They wanted the platform to point them in one way or another, and they felt forced to make like these uninformed decisions under a stressful amount of time. So they're hoping that whatever we built would help them through both of these scenarios. The next one were kind of new ones that we surfaced out. These were from a tier 3 perspective. So the first one is increased working memory. So they wanted to build a better way to enhance detection and recognition with lower end users. A large portion of their day, since there's no real great onboarding process or way to teach the lower end guys like what they should be looking for, they're mentoring these guys and they're spending a substantial portion of their day showing them what they should be looking for. And when that's done over and over again, they're not necessarily telling these guys how they should be looking into alerts. They're just kind of saying what key metadata points they should be looking at, like MD5 hashes or whatever file paths. So it's not really teaching them in any one way or another. So they were hoping that whatever platform we put together, or whatever feature we put together in the platform would allow them to kind of break that apart. And the last one is facilitate discovery and search. So if this was being built in this scenario, a lot of the tier 1s would be flooding up a whole slew of alerts back up to the tier 3. So they wanted a way to help them without moving to different types of products or the command line or anywhere else that could focus in on key areas that they thought were suspicious or anomalous within their environment. So based on kind of these 6 things that we boiled down from all of our user interviews, we boiled those down into 2 different design requirements, which we are trying to accomplish during the entirety of our prototyping phase right now. So the first is the visualization. The attack timeline should be really used as a tool to enhance the typical analyst workflow by providing, obviously, high to low level visibility and context on granular data just in general. So if created correctly and purposefully, it would be able to shine when mapping large quantities of data at scale over time. The next one is something I didn't get into in the last slide, but this was more for the SOC managers and kind of for the tier 1s a little bit. The visualization should be used as a tool for collaboration and reporting. Clear visualization representations in general don't require really anyone to be like a high level security domain expert. Really anyone can understand trends or content distribution in general. What we found, or what we were studying into, where humans are generally just very naturally visual people, and they tend to process data at a faster at-a-glance rate. which, if again done correctly, opens the accessibility of an attack timeline visualization to a larger array of users, which are SOC managers and tier ones who don't have that typical domain experience to it. The next phase, which is the concept phase. So we had a whole slew of different design principles that we were kind of looking into. One was around perception. I chose the one that I like the most, and it's around this guy named Ben Schneiderman. It's his information-seeking mantra, and I'll go through this quickly. Basically, he found that the most powerful visualizations kind of share the same similar traits. And this might be just a duh kind of thing for the rest of you, but it's worth noting and thinking about as you're building a certain type of visualization. So the first one is you want to build an overview first. So it's kind of the first thing the user will see, and it'll guide them through other parts of the product for further exploration. The overview, when carefully planned to highlight important parts of a story, it should be giving lesser weight to like not so critical parts as well. This is also the one that's going to be the most visual, so you should be opening whatever overview, dashboard, whatever to the most critical amount of user testing. The next one is zoom and filter. So once you have all your data presented on an overview section, you want to give that user obviously the ability to focus on particular areas of interest. This involves like zooming and filtering down on data, which is like zooming, scrolling, panning, drill down legends, range selectors, what have you. This is particularly very important for complex visualizations because the zoom and filter functionality will be should be designed in a way where users can't get lost throughout the visualizations. Attack timelines in general are pretty expansive node beasts, so if you leave it up to like a Google map kind of like find and select and zoom, generally if you open too many nodes, it'll be hard to navigate back to where you came from. And the last one is design on detail. Being able to give the minutia of detail back to the user. So this is for the tier 3 case, getting as close to the raw data as possible. This third level would be less visible, but it's more text heavy and kind of focused on accurate information rather than trends. And I'm running against the clock, so I'm going to go through our actual prototyping phases a little bit quickly. So this was our first iterations of what we wanted the attack timeline to be. These were 2 examples of many, many ones we put together. It was kind of the wrong way of going about it. When we mapped it on like a 2D linear perspective, it kind of confined the amount of data that we were putting up on the screen. It also, again, mapped time to a singular axis. We had the correct amount of overview section kind of at a glance stuff there, but it was difficult it was difficult to zoom and filter down on corresponding areas of that node map. We were researching other types of other structures that could house all the information that we were gathering from the user feedback, as well as all the rest of the design principles that we wanted to do. So we kind of went to something called spatiotemporal structures. And these are really meant to map, they're traditionally used for kind of mapping 3D geography in general. A particular use case around it is mapping hurricane patterns of like where a path came from to where I'm running long, aren't I? I'm over.
Other speakers.
Oh, okay, sorry.
We apologize. This was a short talk, and we can take about 1 or 2 minutes at most for questions, so that we can get ready for the next talk.
All right. Sorry. Yeah.
So I saw that you guys do interviews and the split testing amongst the different groups.
Yes.
But sort of, how do you bring like I guess a hard numerical side or like empirical to the testing itself? Like, you can interview a person and they say, this is way better than the last thing, but you guys are probably trying to squeeze the most improvement out. So how do you really quantify that?
We try to not be as biased as possible by like leading them into a certain path of like, hey, this is like, obviously it's going to be better every time the iteration that we come out with is. So we try to show them a couple other designs to kind of move the needle back into the middle to see if this is actually something that they are actually like an improvement on the last iteration.
You guys don't do anything like eye tracking or mouse tracking or?
Not currently yet. We are doing some implementation within the product to do that kind of third-party testing. Yeah.
I think we're going to have to cut it now. So I would like to thank Matthew for his presentation. And see, if you'd like to continue the conversation, go ahead and follow Matthew on Peerlist. Okay? Thank you very much.